while ago, I'd seen on the internet discussion about design of a certain multi-threaded application. It was written in Python. It was supposed to be written in Python. I think they already had some bugs done by this time. And various participants, like some of them were more involved in this process. Some of them were like just bystanders, like myself, for example. And they were asking various questions and making decisions. Like there was like an open discussion and so on. And one thing caught my eye or triggered me a little bit. Mainly, one of the participants asked the question, why do we use a daemon thread for some task here? So it doesn't really matter for the purpose of this video what exactly was this application doing or what was this task. It's just about this single question which has triggered me a little bit because not because of this one particular instance, but because generally I deal a lot with multi-threading, concurrency, parallelism, distributed programming, and so on. And it looks like there are very deep misconceptions present between software engineers or among software engineers, even the senior ones. And so the one guy asked, why do we use daemon thread? And what is the answer that he gets? He gets the following answer, which I've heard already, like something along those lines multiple times, that the daemon thread is just a background thread. As something that runs in the background, and supposedly the non-daemon thread then is running in the foreground. And the second explanation is that is the same thing as detached in C++. And so in C++, you have threads which can either be joined or detached, and we'll discuss about it like later in the video in a greater detail. But just spoiler alert, it's not exactly the same thing. So this is the misconception, and now comes the clarification, or what are my thoughts on this and why they think that it's not really the 100% correct explanation, or maybe even the most vital parts are missed from the explanation. So let's start with daemons. Or maybe not daemons, let's start with threads at all in Python. So we have threading module, and we can create thread objects. We can also inherit from the thread class and create our own thread classes and redefine the behavior. But generally for the thread, the real thread from the threading module, you will have to start it explicitly. And so first you create an object, and it doesn't do anything, and you will have to call start method explicitly. And once you call it, then probably run method will be triggered. And what will be run inside the run method? Well, what you provided as a parameter to the init, the parameter which is called target. Yeah, so it has to provide some kind of what we call, usually not target, but callback more generally. And this could be a function in like in a lot of sense, but can also be a class which has the call method like this underscore call underscore overwritten. You can also do that. That would also classify as callback. And then it's then whatever you define inside this target that you have provided for your thread will be the thing that will run, and it decides about everything. Yeah, so if you think about foreground versus background in a classical sense, that the background doesn't interact with the user, then in that sense it all depends on what you have specified for the target. You can create a thread which you then set as daemon. There is this daemon flag which is by default false, and you can set it to true. And in this sense, it doesn't influence, this daemon flag doesn't influence at all what your thread will be doing. It's all about the target. So whether you will interact, for example, with the user, you will ask it for some input, you ask the user for some input, or maybe you will sell something on the screen or something like that. So classical examples for foreground versus background, that all depends on your target. The daemon flag doesn't influence anything at all here. It's all about the target. What your thread will do is decided by what you have defined in your target. And all those additional stuff, things like daemon versus non-daemon and other things, might not even play a role. And that's what I'm trying to get into, but let's stay patient and we will get into it in a couple minutes. So the next thing is scheduling and context switch. And so the operating system decides when it will switch between the threads. So if you have more threads than cores, and of course in Python there's also the issue with Jill, but we'll not get into it right now. But generally, if you have more threads than you have available cores, then some of those threads will be waiting, and so there's more stuff into it. But let's just stay with this simplistic view, and we'll explain it in greater detail in some other video. But some threads are waiting and some threads are running, and when the switch occurs, it occurs in unexpected moments or the moments that we cannot predict or control. It's all decided by the operating system. And again, what is the role of daemon here? There is no role that it plays. Not at all. There is it doesn't influence anything about scheduling, about the priority, order or execution, or anything like that. And so again, if this is a thing that you're thinking about when you say foreground versus background, then again you are wrong. But there might be a sense in which this foreground versus background execution does really make sense, but it's very specific, and I think demands a little bit of additional clarification. So we have clarified so far the thread class, its main task, how it works, what it does. By the target function, we talked about scheduling a little bit. So finally, we arrive at this daemon flag, which we have already set. By default, is set to false, but sometimes you can set it to true. And hence now, what does it change? So the main question, it changes almost nothing. And for some cases, it will really change nothing. So the only case in which your daemon flag will play any role at all, in which it will influence something, it will change behavior from default to non-default when you changed the flag from false to true, is an event of shutdown. But also not all shutdown events, since not all shutdowns have been created equal. So let's first discuss the most common case, maybe not common, but the most like standard case, and then let's discuss all sorts of other cases which are also common. So I guess the commonality or how frequent each case occurs in nature has to be studied, but you have to decide on your own for each application separately. Yeah? What kind of case you are dealing with, or what kind of cases you are anticipating. So the first case is that you have an application which does some work, has some task to do, and then it terminates. Yeah? Maybe it had to write something to like some statistics or some kind of data to files, and maybe it had to do some computation, and it reached some point in which its task has been fulfilled. And then the main method or the main thread wants to exit. And in this case, there is a difference between daemon versus non-daemon. And you can imagine it as a party in which you are the main thread, you are the organizer, and you have invited various guests, various other threads. And in case of non-daemon threads, when you want the party to be finished, or you want to make the guests leave, you will be very polite with your normal guests, your normal threads. And so you ask them to pack their stuff, but you will wait politely for some time, of course, not too long, until they pack their stuff. They have they run their cleanup policies or their cleanup procedures. Maybe they were in the middle of database transaction. Yeah, so in this case, you will wait politely till the transaction is complete. You don't want to cause any failures or any kind of errors on the database side. Maybe there were some files still open and you want to close the file handles, and so on and so forth. Yeah. So in case of normal threads, you will allow them to execute their cleanup policies. Or even in another case, there is also this case of join versus non-join, which we'll discuss more on the C++ side. You may wait for a longer time, not only for the time that they are running their cleanup policies, but even maybe they had some task to do and you want this task to be complete. But this is the case when the main thread wants to exit and you have still some other threads running, some other threads present at your party, and you have daemons versus non-daemons. Yeah? So for non-daemons, we know what happens. You want to be polite, but for the daemons, the bad daemons, they stay somewhere maybe at the back of your living room. They do whatever they do. That doesn't matter. You don't care. Those are just daemons. You don't respect them at all at this point. You take them by the back and you throw them away. Yeah, so you don't let them execute their cleanup policies. And this is where it matters. So if you have any kinds of resources that you're using, and of course there are all kinds of resources that we talk about when we talked about threads or processes and so on. There are those resources, like I said, maybe some database transactions, maybe some network connections, maybe open files. There might be also resources within the program itself, yeah, so some shared memory, stuff like that. And finally, there will be resources on the operating system side, like the operating system. And the kernel itself keeps track of the threads that are running, keeps track of the scheduling. It also allocates the stack memory and so on. So those kind of things, how much do you care about them depends, first of all, on the language that you're using and on the particular application. But in case of a daemon thread, you don't care at all, or you signal that you don't care at all in this kind of event. But there could be different scenario in which, for example, you give very short-lived task to your thread. Yeah? And this task will be finished before the main thread wants to terminate, or the main thread closes. In this case, there is no difference between your daemon versus non-daemon, because they finish either way. And so it only influences a shutdown policy, and in a very specific case of shutdown. Then there is also an issue when, maybe not an issue, a case in where your application is still running. The main thread hasn't finished yet. It still wants to run, but there is a signal issued from outside of your application. Maybe some other user on the server or some other process has issued a particular signal which will cause your application to close. And you have a difference between zigterm and zigkill, yeah, in which zigterm for Python at least, there is a signal handler by default implemented that will cause certain cleanup routines to be executed when there is a zigterm issued. Yeah, so there is already something by default in Python there. You can create your own signal handler, which in addition will do something else, and then you have a, you have a decision to make. Maybe you will still do something with your daemon or not. Yeah. So in this case, what will happen in case of your own signal handler depends 100% on you and what you will do. But in case of the default signal handler, then some procedures may run, and the daemon will be ignored again. He will be just kicked out of the party. But in terms of a Zig kill, the whole process has to terminate immediately. Yeah, it closes the whole process and all the threads within the process. And in this case, there is again no difference between the daemon versus non-daemon. So all of their procedures for cleanup will be ignored, and everyone will be treated as badly as a daemon. And those are like some cases to some food for thought to think about when it comes to the shutdown policies. So where is this background versus foreground distinction coming from? For me, I think the only thing that I could think about is, again, the event of shutdown, or to be precise, not where, but when the shutdown is triggered. So if you have just daemon threads which are running and all other threads have finished, in that case, your application will shut down. But, there is a but, it will only shut down if you did enjoy your daemon threads, because daemon threads are still joinable. Yeah, and here is this big misconception between detached and daemons. So this detached that exists in C and C++, and daemons which are in Python and Java. Detached are the opposites of joined. They are not joinable, but daemons can still be joined. And that's why I think a lot of this confusion, or that's where a lot of this confusion is coming from. Yeah, so in this one particular case, you may think of the normal threads and plus the daemon threads which are joined as the ones that are running in the foreground and keeping your application alive, and then those non-joined daemon threads which are somehow in some kind of background. And if only those are alive, then in this case, your application will close. So I think that's it about the Python stuff, or at least we have covered most of the introduction. Now let's go a little bit deeper into C++ and joined versus detached, where we have again threads which we can create, and once you create, then they start immediately, as opposed to Python where you have to explicitly call the start method, and by default are joinable. And then you are supposed either to join the thread and wait till its execution finished, or you can detach, which is an opposite action to join. But now, what kind of consequences it has? So join versus detach has also some influence on shutdown policy, but it's mostly about resources, yeah, and the resource cleanup. So in C++, you care about resources much more than you care about them in Python. Of course, you can also, at some level, have issues with resources in Python, but the language itself, or the interpreter, takes care of a lot of stuff behind the scenes. Yeah, and those kind of stuff that are done implicitly in Python, you have to do explicitly in C++. So if you detach a thread, again, here will be a difference between short-lived versus long-lived thread. If you detach it, there will be a cleanup done by the operating system, which will be triggered immediately once the thread exits. Yeah? So if you have a short-lived thread in C++ and you detach it, then everything's okay. And all the stuff that was allocated on the operating system side, like the stack memory, like the registers in the kernel or whatever, or like whatever keeps track of your thread on the kernel side, will be cleaned. Yeah? If you don't do it, and you neither join nor detach, you will have a leak at this point. Yeah? So you have the case of short-lived thread. Other threads are still alive. Application is still running. This one thread that you have created has completed the task, and you didn't detach nor join. You have a leak. And of course, if you have too many of them, this can be problematic. You are losing RAM, and there is even danger of crash. So your whole application might crash at this point. If you will try to access something, or your main thread or other threads will try to access something from this thread, which still hasn't been cleaned properly, but we don't know about it. So the only case in which we have an intersection between detached and Daemon threads is this case where all other threads have finished in our application, and in case of Python we have only daemons that were not joined. Then the application will close. Or in case of C++, we only have detached threads and all other threads have finished, then we also close the application. And in this sense, we can think about them both as background threads. Yeah, but it's not the fact that either you detach them or you set the daemon flag to true. Is rather the application that you use them for. Yeah, so makes sense to do some kind of background work, so to speak, to stay within this terminology in both cases, like maybe logging, maybe some telemetry, maybe sending some metrics to some database or some server outside. And once all other threads have finished and we only have those threads running, then probably there is no need for sending any additional logs or saving any additional logs or sending any additional metrics. And in this case, you may think about them as like background tasks. Yeah. But to use Daemon for such thing in Python is again questionable, since you are running into this problem of not the in-app policies not being respected. Yeah, so if you had some kind of database transactions or network connections or open paths which are closed with no proper shutdown, no proper cleanup, and closed in the middle of the work, then maybe it's not really a good idea to use a daemon for such case. But it really depends on your particular case. Maybe you don't care, and in such situation, maybe it's just some housekeeping which can be stopped in the middle of the work and then resumed after. It all depends on your particular case. I guess there are no like hard lines in which we could say that this always has to be daemon, or just always this never should be daemon. I think maybe in the second case, yes, there are some things which never should be a daemon, but for the first case, there are no hard lines, especially because in Python you don't have to join at all. Yeah, it's not like in C++ where you care about those processes. You can just start a thread and let it run, and not set it to daemons and never join it. Yeah, and then it can do your background task however long you want, and do whatever you specified there for it as its work. Yeah, so that's C++ versus Python, threads, and so on. And now let's maybe discuss the last part. Where is this Daemon part coming from? So, to the best of my knowledge, Python was introduced in the 90s, and the most modern language at this time from which Python took a lot of its ideas was Java. Yeah? And Java was the first language that used that Daemon terminology for its spreads, and that's where it's coming. And now, where does Java get it from? Well, it gets it from Linux or Unix, or Word to be more precise. And then we have the daemons and services, which are a little bit different concept, but again, here they really are something of a background versus foreground thing. Yeah, so in today's world, we have systemd, which is a service manager. And again, what are services? So services are like a wrapper, maybe, or not even a wrapper, some concept on top of daemon, which daemons are processes that do stuff which is supposed to be run in the background. And most of the current Linux distributions use systemd to start certain services or certain daemons, which here are not threads but processes in the background without user intervention. And so here is this background stuff. You start them at the boot up, and then the service manager also monitors them. It can restart them, it can stop them, and this is all different to what we call daemon in Python. So the daemon in the Linux world is a little bit different concept, but maybe there is this very slight intersection in when it comes to this background versus foreground thing. Yeah. So here is the history of daemon, and if you have like any other explanation or anything in addition to that, you can share it in the comments. Other than this, I think the last thing that I wanted to talk about is what is the consequence of misusing a daemon. And so it can have its consequences, but only, again, a very particular case. And so if you have a case in which you specified some work that you want to be completed, but you set it or you delegated it to a daemon thread, then you run into the scenario where only daemon, which is non-joined, stays alive, and in this case, maybe the application shutdown will be triggered prematurely. And the opposite case would be if you have some background task, again, this time a real background task, and you delegated it to your daemon thread, but you want the application to close. But, you delegated it to the non-daemon thread which joined. Or maybe to the daemon thread that you joined. And in this case, your application will not close, even though all other work has been completed, but you're still waiting for this joint thread, which is supposed to just do a background stuff and not block the system shutdown. So there could be a case in both directions where you misuse it. That's why it's really important to understand everything that happens behind the scenes. Maybe not everything, but at least on high level, and what are the consequences to be able to properly use the tools that we have to our disposition. And that's it for this video. We'll talk more about multi-threading and other concurrency related topics in the next videos.